Before we start this video, a large thank you to Jaden, TW, Mew, Roberto, and Caden for their support on Patreon. I hope you guys enjoy the video. And, as always, an immense thank you to Halo Burner for their continued support of the channel this month on Patreon. It is greatly appreciated, my friend, and I hope you enjoy the video. Hello guys, some of you may be looking at the title and thinking, what is slope sliding? Well, I'm going to show you an example in game. So I'm in Nephilim right now, this is my project. If you guys want to see more of this, you can check out in the description. But, if I jump on a flat surface, yeah, this is cool, I'm supposed to be here. I can jump on this crate, that's fine. But what happens if you don't want the character to jump on something like, say, this stalagmite? Well, the effect in Elden Ring is you'll do something like this. I'm going to jump up here, I don't want the player on it, so I slide off. And this is what I'm going to refer to as slope sliding. So there's certain geo in your map you don't want the character to jump on top, like these stalagmites for example. Same thing's happening right here. And another good example of that would be a character's head. So I'll just jump over here and see if I can maybe get on this guy's head, or try to. Just pay attention to what happens. I'm going to leap up here. I think I can do it. Yeah, I can jump that far. So if I jump on his head, you probably can't feel that like I can, but I'm just sliding off. I'm kind of going through his head and then popping off. And Elden Ring does a similar thing in Dark Souls. You don't want to be able to stand on someone's head. It just feels really weird. Or maybe you do. I don't know. Depends on what you want for your game. But, nevertheless, that is what we are going to cover in this video. Sliding off of slopes and characters as by popular demand from a bunch of people in my Discord. Thank you for the weekly @Sebastian reminders. Shout out to Bark Mober. Hope I'm pronouncing that right, bro. And Disabled. I hope you guys enjoy the video. Okay, so we're going to start by going to the Character Locomotion Manager. And we're going to open that up. And this is going to be default for all your characters, unless you don't want it to be, in which case put it on whatever character manager you want to have it. But I make a comment here called slopes and sliding. And I'm going to make a function for private void set falling slope slide velocity. Now you notice I said falling there. That's because it's going to behave a little bit differently when you're falling. At least I think this is a much better system. Because it makes more sense that if you have a lot of velocity in your fall and you come across a surface, you know, the angle at which you define it to be slippery will be a little bit more steep, or less steep, than if you were just walking normally. Because you're more stable when you're walking around. When you're falling in the air, it's a bit harder for you to catch yourself as compared to walking. So let's make a vector 3 start position and initialize that at our character, but +1 on the y. Now if you don't like magic numbers, which I understand, you can make this into a variable if you want, but we don't want this at the base of the character because it will behave irregularly. In my testing, it's best to have it just a little bit above the character. So we're going to say header slope sliding, and we're going to make a serializable field for the float for this number, and I'm simply going to call it slope slide start position offset. Or we can say start position y offset to be super particular, and I'm going to initialize it at 1. And again, play around with this if you have different size character models and whatnot. This is just what works for me. If you're using something along the same size as Cinti model, this should work for you perfectly. If physics sphere cast, so we're going to do a sphere cast, we're going to start it at our start position. We're going to make it the same size as our ground check sphere radius. This is very important. Make sure you keep that the same. And then we're going to project it down using vector 3 down, and we're going to say out raycast hit. We're going to call this hit info. So we're going to keep this variable. And now over here where we have the max distance, again, I'm going to say 2, but if you don't like magic numbers, because I understand why you don't like them, you can make a variable for this too, and you should. Honestly, it's better practice to make variables for this stuff, especially if you're working in a team. I'm going to call this slope slide sphere cast max distance, because that is exactly what it is. And it's really hard to not understand that variable name. And I'm going to pass that instead of our 2. Okay, and now lastly is the layers that we're going to cast this on. And I'm going to say world utility manager instance.getGround. No, I'm not. Why is this not a variable? I could have sworn we made this. One sec, I'll be right back. I'm going to check this. Yeah, okay, so I was looking at Nephilim, and we did make this, but it is called something a little bit different. We don't call it getGround layers. I believe in this project, I called it getEnviro layers. So we're going to use that. And if you call it ground layers, that's cool. I did call it enviro layers on this project. So we're going to cast this on those layers only, and we're going to say float angle is equal to vector 3 dot angle, and then we're going to pass our hit info dot normal, and then we're going to say comma vector 3 up. So we're getting an angle based on this, and we're going to use this angle to determine if it is too steep or not when we actually touch the surface. So we can do that by saying, first let's make a private vector 3 for our slope slide velocity. This is always going to be the velocity you have stored up if you're going to be sliding. So for now it's not anything, but we're going to say slope slide velocity is equal to vector 3 dot project on plane, and we're going to pass a new vector 3, and we're going to use 0, and then we're going to pass a speed variable, which we don't have yet. So just pretend there's some imaginary speed here. I'll make that in a second. I'll call it my speed here. I didn't want that to autofill. And then we're going to pass a 0. All right, and then we're going to pass comma hitinfo.normal. And why am I setting this up in this manner? Well, we want to make it so when you're sliding off of something, it makes sense that you slide off in the proper direction that you're hitting, depending on the hit information normal, basically. So, for example, if I go up against a cliff and I hit a wedge of a cliff, I want to slide off that wedge where it makes sense. You know, I don't want to go over the wedge some random way that wouldn't make sense. So let's make a slope, slide, speed, velocity. I'm going to set mine at -11. And then I'm going to make another serializable field here for a float again. And I'm going to call this the slippery surface max angle. And we'll say 15. So this is the angle which it's going to be like, nope, you can't do this. It's too much, too steep. And then you're going to start sliding a little bit. So we're going to pass that slope, slide, speed here, where I had that all caps name. And then I'm going to say if the angle is greater than or equal to the maximum angle that we've made, so slippery surface max angle, we are going to then apply some logic. We're going to say the slope slide velocity is equal to vector 3 dot project on a plane, new vector 3, 0, slope slide velocity, 0, whoops, slope slide speed, sorry, 0, hit normal. And you may be thinking, why are you typing this again? It's up there right as it is. Well, this is optionally if you want to replace the slope slide speed here with a different speed. Like for example, since the angle is past the maximum slippery surface angle, you can make the speed more intense here. But for now, I'm going to leave it just like that and test it and see, because you might not even need this line. It could be redundant. But for some surfaces, you can replace the speed here to something more intense. Otherwise, slope slide velocity is equal to 0. Okay, so next we're going to say if is sliding, which we don't have made yet, don't worry. So let's go up and actually just make that right now, actually. Let's make a private bool for is sliding. Is equal to false. And then come down here again. And then we're just going to do a check in here. In is sliding, we're going to say slope slide velocity minus equals slope slide velocity times time.delta time. And you can make a modifier here if you want to basically make it increase a lot more over time. So if I was going to do that, I can just copy and paste one of these variables because, again, magic numbers are generally bad. Just make sure you name it something that you understand. So slope slide speed multiplier, and I'll say 3. So over time, it will just basically gradually make it much more intense. So we can say times slope slide speed multiplier. Okay, and I'm going to say use a sphere cast to determine basically if we're getting anything in the enviro layers and what angle it is, what's below us. And again, guys, this is only what I've done in Nephilim, so you may want to tweak some of these numbers and such. Obviously, this works really great for me in Nephilim. This is used in the project I showed you the first of the video. So this is just my approach on it, and I'm sure there are ways you could optimize this, make it a little bit nicer or neater. This was something I never even intended to show on video, but I was asked about a bunch of times, so I'm kind of just ripping some of my notes from here now as I'm going. So if I make any mistakes, also please point that out if you see something that is redundant. So right below it now, we're going to say if slope slide velocity at magnitude is greater than 1, we're going to simply return. And then lastly down here, we're going to make sure we just say slope slide velocity is equal to vector 3 dot 0. Okay. Now, we have a way, you're going to notice too, I've said this is falling velocity. Well, why is that? When we're not grounded, things should be more slippery, so we check for our regular ground layer as well. But when we are grounded, we're only going to check for a slippery layer. So basically, you can slide off of everything when you're not grounded, and if you're not in the middle of a jump. Otherwise, you should only slide off of what's slippery, okay? So certain objects in your game will be tagged as slippery surfaces. But when you're falling past a certain point, everything that's greater than a certain angle is going to be slippery to you. So we're going to say set slope slide velocity. This is a new function. We're going to say if slope slide velocity is 0, we're going to say is sliding is equal to false. And if we're not grounded and we're not in the middle of a jump, so let's come out here and make a variable first for private bool slide until grounded is equal to false. Okay. If we're not grounded and slide until grounded, then we're going to say set falling slope slide velocity, and then we can say return. Okay, so what happens if we are grounded? Well, we're going to do the exact same thing, but we're going to apply a different layer, basically. So we can actually make this code a bit more lean in a second, but we'll get to that. So first off, if we're not grounded, return. We don't want to process this if we are in the air. Otherwise, you can quite literally take all of this and paste it, but we're going to change the layers upon which we call. So we'll make this a bit neater and clean this up in a second and just condense this down to one function instead of calling all this logic twice. All right, so first thing we're going to do though is go and make that layer. So what we want to do is actually make sure we copy this as well because this is equally as important. And then we have get enviro layers. We only want to do this one on the slippery layer. So we want to go into our game and make that new layer. And to avoid confusion, I'm just going to name it the same thing as the enviro layer that we use, which is default. So I'll call it slippery default. And instead of get enviro layers, we'll call get slippery enviro layers. So go to any object that you have and go to your layers here to make a new one. And again, default is my enviro layer in this game. So I'll add another one and I'll call this default slippery or slippery default. So it's going to act as the exact same thing as default. It will be in our ground check, but this one will have an extra step of being checked for as a slippery surface. So go to your World Utility Manager now and make sure you add slippery to your enviro layers as well, because like I said, this should still count as an enviro layer. And then we're going to make another, you can use a getter or you can use a public reference. I think I was showing get functions here a long time ago in the series. That's why I'd make these public, the variables I mean. So if you want to do the same thing, you can just serialize it, and then you could say slippery enviro layers, make a function for get slippery enviro layers, and return the slippery enviro layers. And I'm going to make this default slippery and nothing else. Okay, very good. Now I'm going to go back into the project, and then handle slope slide check. Let's rename that to handle slope slide check, and let's rename set falling slope slide velocity to set slope slide velocity. And then we can just make it require a layer mask. And then instead of typing all this out twice like so and wasting all this space, we just make it require a layer mask. And then depending on where we're casting this to, we just switch out the layer mask. So I'm just going to basically eradicate all the functionality I just pasted. And then we can simply call the function. And that's a lot neater and less confusing. So making modifications in one place instead of two is always better. If you want to basically make code like that, you should never, or at least as little as you can, copy and paste the same logic, because if you go back and change it in the future, you got to change it in two places and you're more likely to make a mistake. So I am going to come up here now and just do the proper layers, get enviro layers and get slippery enviro layers, and now it looks just like that. All right, very good. Now I'm going to come right below set slope slide velocity and make a private void for set grounded velocity. And this is basically going to apply the new velocity that we just set to the character using the character controller.move. Okay, so if you're ignoring gravity in your game, I don't think I've covered that yet in this tutorial, but if you are, please ignore this function and return. Just do a check for if it's ignoring gravity, simply return. Otherwise, that will mess with any system you have that will make your character float or fly. So if slope slide velocity does not equal vector3.0, what we want to do is say if the character.character network manager is jumping and the velocity has not reached its peak. So if you're not going down yet, that will mean your y velocity is basically .y specifically is greater than 0. Then what you want to do is set is sliding to false, because you can't slide if you're still gaining altitude from your jump. You still have power in your jump. We don't want to mess with that. Otherwise, is sliding is going to be set to true. Now we can say if you are in the process of jumping, and your jump has not reached its maximum height, or you're still gaining altitude, you don't want to set is sliding to true. Otherwise, you'll start sliding off of stuff in the middle of your jump, and that just feels weird and looks weird. Okay, now we're going to say if is sliding, then we're going to say y velocity dot y is plus equals slope slide force. So this can be a global force if you want it to be the same for everybody. So a good idea to make this is somewhere on your world utility manager or a world manager where you can access this. If you want to be different for every character, make this a variable on the character locomotion manager. So I'm going to make it on the world utility manager. It doesn't exist yet, but then we're going to times that by time.delta time. So Slope slide force, I'll make it here. I'll make it public. I won't use a getter method here. I'll just make it public so we can grab it. If you are working in a project where you think you can accidentally change this, you should use a getter method. So public float slope slide force is equal to -15, we'll say. And this is just a number I picked from Nephilim. You can change this if it's too fast or too intense. You know, you can make all these modifications depending on how you want it to be. Mine is very quick. It kind of mimics Elden Rings. Like if you go on a slippery surface, you're going to jet down very, very quickly. So vector 3, slide velocity is equal to slope slide velocity, and then we're just going to apply that velocity on a character controller. You might want to check to see if your controller is active if you turn them off any point in your project. If you're doing certain actions that will disable it. So we're going to say if the character controller is enabled, character.character controller, and then we're going to use a move, and we're going to move the character by our slide velocity times time.delta time. All right, cool. So why are we adding on to our y velocity.y? Well, that applies when we're not in the air, as you would remember. So if we are grounded, else. This is where we're going to handle the character on character's head bit on the else, but we'll get to that in the next video. If y velocity.y is less than, we'll say, the 0, and you are not sliding. So if you have a force less than 0 and you aren't sliding, we're going to say y velocity.y is equal to grounded y velocity. All right. Otherwise, again, this will handle our sliding off of a character's head check, and there's a bunch of ways to do this. I'll show you a couple, and I'll show you the one I landed on and why. And then down here, we're going to say if the character.character controller is not enabled, just simply return. There are certain situations where I turn off certain AI controllers for a second for special logic. Maybe you don't do that, but I just have to check here because of that. Now, if there is a desync, this should never happen, but it can happen in really weird, obscure ways. So this is just a measure to stop that. So we're going to check the distance, or rather the position of our character. Only do this if you're not the owner. So this is a netcode thing. We're going to say float distance is equal to vector3.distance, and we're going to pass the transform.position, and we're going to compare it to the network position of this character, because that's the true position of the character on the server. And if there is a discrepancy between that of, say, greater than 2.5, we're just going to basically set a velocity to 0 and resync to that position. And again, this should almost never happen, but it can happen in really weird freak accidents. And if it does happen, you don't have this check, your character will just basically endlessly slide forever and it will never resync back up. And you don't want that, so this is here as a precautionary measure. We can say y velocity is equal to vector3.0 to stop that continual downfall. And we can say character.transform.position is equal to character.character network manager.network position.value. So this is just a precaution. You should have this here. It can save a character from endlessly falling into a void if some really weird stuff happens. So we're going to save that, and let me check my notes. I think I'm not missing anything. I think we're good. Yes, okay. I mean, I'm sure I'll figure it out when I start the game. So let's go to update, and we're going to call upon the set grounded velocity, and then right after that, we're going to call upon our handle slide check, slope slide check, just like that. And now we're going to save that. Now we're going to go into the scene and place. I'm going to place a stalagmite, just like I showed in Nephilim. It's even from the same pack. I'm going to set the layer to default slippery. And I'm going to go into the game here in a moment, save the scene, and try this out. So let's go back to the main menu. And I'm going to show you what does happen if you forget to do something. So if we go into the game, and I jump on this right now, it's actually not going to work. Watch this, I'm going to float. So I'll go to the stalagmite and jump. You can see here I am levitating. Why is that? Well, we have our ground layers on our character locomotion manager. That's why you might want to put them on the world utility manager and set them globally, because if you don't remember to set the default slippery as also a ground layer, you will float when you hit it. Now if I click it, boom, I slide off. Check that out. So let's stop the game, or you can keep it going. Go to your prefab, or again, you can get these layers from the world utility manager if you want, so they set them locally. But if you're going to set them locally, set default slippery also as one of your ground layers. And now when I jump up on the surface, you can see I am in fact sliding off. Very cool. Excellent. So that is working as intended. Now, nothing right now would happen if you still have a character, because there's nothing that's set up to do that, unless you tagged a character layer as your ground layer also. But I'm going to show you what I would do instead. So we're not quite done yet, because if you may have noticed, we didn't actually utilize slide until is grounded. We're going to add an on is grounded check and on is not grounded check whenever your grounded bull switches. And we're going to basically toggle that on and off, and that will make it feel even a little bit more better than it already does in certain weird situations when you're sliding off of interesting geo. But other than that, in the next episode, we're going to add a functionality to slide off of a character's head or face through the character, and I'll show you why I chose what I chose. So again, this was one of those systems that I really had no intention of showing on YouTube, but it was asked by popular demand. So it is not as neatly laid out or explained as some of my other videos. I kind of wrote this one with the intention that I'd be the only one to ever kind of view it. So I wrote it how it would make sense to me. So you may want to change the structure or how it kind of reads, depending on what works for you. So I hope you guys learned something. Thank you very much for tuning in. A shout out to my Patrons. It is because of each and every one of you that the series may continue. You have my sincerest gratitude. I hope you all have a very lovely weekend, and I will see you next week.